Hello, everyone. As we know, in mechanical disassembly and assembly work, choosing and using the right tools is crucial. A small mistake in tool selection could lead to low efficiency, damage to parts, or even cause safety accidents. As the ancient saying goes, if a man wants to do his work well, he must first sharpen his tools. Only by mastering the correct usage of various tools can we handle practical operations with ease. In the last class, we studied wrench-type mechanical disassembly and assembly tools. In this class, we will continue learning about other mechanical disassembly and assembly tools. Through this class, we hope that you will 1. Understand the types and uses of common disassembly and assembly tools. 2. Master the correct methods and precautions for using these tools. 3. Be able to choose the right tools according to the situation and practical operations, improving work efficiency and quality. First, let's learn about the screwdriver, also known as a screwdriver, slotted screwdriver, or flathead screwdriver. It is a hand tool used to tighten or loosen bolts or screws with a slot, such as slotted and Phillips screwdrivers. When using, start slowly and apply even force. When disassembling or assembling, hold the handle of the screwdriver with your right hand. Place your palm against the end of the handle and ensure the screwdriver's head is perpendicular and fits snugly into the bolt or screw slot. Apply even force, as uneven force may damage the screw or injure yourself. When starting to loosen or tighten, press the screwdriver tightly, and then use wrist power to twist it. After the bolt loosens, you can use light pressure to twist the screwdriver quickly with your thumb, middle finger, and index finger. Select the appropriate screwdriver based on the type and size of the screw. For example, use a slotted screwdriver for slotted screws and a Phillips screwdriver for cross screws. Never use a small screwdriver on a large screw or a large screwdriver on a small screw. When tightening screws, the screwdriver must not be tilted. It should be perpendicular to the workpiece to avoid damaging the screw head. The second tool is the puller, commonly used to disassemble rolling bearings, gears, pulleys, flanges, and various disc parts, as shown in the figure. Common pullers include 2-jaw or 3-jaw types, which can use either mechanical or hydraulic methods for disassembly. When using the puller to remove bearings or gears, the pull hooks act on the inner ring of the bearing. By turning the handle screw, the lower part of the screw pushes firmly against the shaft end, pulling the bearing off the shaft. Hydraulic pullers use hydraulic pressure to move the central pushing rod forward without rotation. The hook seat can move forward or backward with the threads to adjust the distance. A small swing of the operating handle can push the hydraulic starting rod toward the shaft end, causing the hook claws to retreat and pull out the bearing. The third tool is the chain cutter, used to cut or connect chains. When using a chain cutter, first check the chain, lay it flat, and slowly apply pressure to either separate or compress the chain after installing the cutter. Ensure that the cutter is tightly fitted to the connection point of the chain during installation to avoid damage caused by improper installation. The fourth tool is the copper bar. With high conductivity and ductility but lower strength, it is used to tap components into position without deformation during assembly. Hold one end of the bar and tap the component gently and slowly. The fifth tool is the hammer, a striking tool categorized into metal and non-metal types. Common metal hammers include steel and copper. Non-metal types include plastic, rubber, and wooden mallets. Rubber hammers can prevent deformation of workpieces during striking. For precision workpieces or hardened surfaces, use softer hammers to avoid damaging the workpiece surface. Before using a hammer, carefully check that the hammerhead and handle are securely connected to prevent accidents from the hammerhead coming loose during use. If the hammerhead has burrs on the edges, they should be ground off to prevent injury in case of breakage. When using a hammer, choose the appropriate material, size, and shape based on the nature of the work. The sixth tool is wire cutters, a tool used for gripping and cutting. Wire cutters consist of the jaws and handles. The jaws include the gripping jaws, notch jaws, cutting jaws, and bending jaws. The cutting jaws can be used to cut soft items like electrical wires or iron wires, while the notch jaws are used to cut harder materials like steel wire. Do not use wire cutters as a wrench or substitute them for a hammer to strike other workpieces. They should not be used to pull nails either. The seventh tool is needle nose pliers, also known as bent nose pliers or long nose pliers. It is a commonly used plier type tool consisting of a pointed head, cutting edge, and handles. Needle nose pliers are primarily used to cut smaller diameter single or multi-strand wires, bend loops in single-strand wire joints, strip plastic insulation, and work in tight spaces. The eighth tool is diagonal pliers, also known as diagonal cutting pliers. They are commonly used by electricians to cut metal wire, excess leads from components, and nylon zip ties, but should not be used as a substitute for regular scissors to cut insulation sleeves. The ninth tool is a wire stripper, which consists of a cutting edge, wire compression opening, and handles. The handles are covered with an insulated sheath rated for 500 volts working voltage. Wire strippers are used for removing the plastic or rubber insulation from electrical wires or cables. To use, place the end of the wire to be stripped between the cutting edges, squeeze the handles, and then release. This action removes the insulation from the wire core. The 10th tool is snap ring pliers, also known as circlip pliers, a specialized tool for installing or removing internal and external snap rings. To remove an external snap ring, use the shaft snap ring pliers, which are normally closed, but when in use, grasp the handles to open the jaws and pull the ring off the shaft. To remove an internal snap ring, use the hole-type snap ring pliers, which are normally open, but when in use, grasp the handles to close the jaws and pull the snap ring out of the hole. Both shaft and hole snap ring pliers come in straight and angled types, depending on the specific application. The 11th tool is a bench vise, a fixture mounted on a workbench for holding workpieces. The bench vise must be securely fixed to the workbench with 2 clamping screws, and the jaws of the vise must extend beyond the edge of the workbench. When clamping a workpiece, the handle should only be turned by hand, not struck with a hammer or turned with a socket wrench, to prevent damage to the screw, nut, or vise. Regularly oil the screw, nut, and other moving parts to keep them clean and lubricated. The 12th tool is pipe pliers, used to grip, tighten, or remove various pipes, pipe fittings, or round parts. They are commonly used in pipe installation and repair. The body of the pipe pliers can be forged or made of aluminum alloy, which makes them lightweight, easy to use, and resistant to rust. Choose different sizes of pipe pliers based on the diameter of the pipes you are working with. When using pipe pliers, tighten clockwise and loosen counterclockwise. The adjustable head is used to clamp the workpiece, and failure to follow the correct direction may cause slippage and even injury to the operator. The adjustable travel range on the pipe pliers indicates its working range. We have now learned about common mechanical disassembly and assembly tools. In actual use, we should follow the tool selection principles. 1. Choose the appropriate tool based on the nature of the work and the type of parts. 2. Check the tools before use to ensure they are in good condition and avoid using damaged tools. 3. Operate the tools strictly according to their instructions to avoid accidents caused by improper use. 4. Clean and maintain tools after use to ensure their reliability for the next use. Through today's lesson, we have gained a deeper understanding of the usage methods and precautions for various mechanical equipment disassembly and assembly tools. Correctly choosing and using tools is crucial for improving work efficiency, ensuring quality, and maintaining safety. I hope everyone will apply this knowledge flexibly in actual operations, select the appropriate tools, and ensure smooth disassembly and assembly. That's the end of today's lesson. See you in the next class.